In this video, we're going to be talking about special right triangles, two different cases. In a previous lesson, we talked about how if we knew that two legs were 3 and 4, we automatically knew that the hypotenuse size was 5. Or if we knew that two legs measured 5 and 12, we knew that the hypotenuse measured 13. So in those two examples, we were talking about the length of sides. In these next two examples, we're going to be talking about angles mostly. So that's our focus. In this first example, we're looking at a right triangle that has two 45-degree angles inside of it. So we always have this 90-degree in a right triangle. If we know that one of those other angles is 45, then automatically this other angle has to be 45 in order to give us a total of 180 degrees. And whenever we see this, we have a special right triangle. In this case, if we have two 45-degree angles, our two legs, A and B, end up being equal. They're the exact same size. So our legs are equal. And our hypotenuse, which is still the letter C, and it's still across from the 90-degree angle, our hypotenuse is going to be whatever the leg is times the square root of 2. So you could say it's A times the square root of 2 or B times the square root of 2. Whatever the length of our leg is, that's the number that's going to be attached to the front of our radical 2 here. And if we add a calculator, we can multiply those two values together and get a decimal value for our length. So some people use a ratio table to talk about these two different values. We got our leg and we got our hypotenuse. So I'll use some shorthand there. The leg is always going to be a value x, so a number is going to replace that. And the hypotenuse is always going to be that value x, whatever number it is, at the front of the square root of 2. So those two numbers being multiplied to give you the length of the hypotenuse. So let's apply that. Here's our first example. The easiest one is if you're given the leg and you're missing your hypotenuse length. Because like I said, all we do is we stick that value of the leg or the length of the leg with the square root of 2 and we have our hypotenuse. So let's try it. We could use our tables here. Our leg is x. Our hypotenuse will be whatever that is times the square root of 2. So because we're given a leg value, it's 12, then we stick that at the front and replace or substitute x with 12. So our hypotenuse value or length is 12 times the square root of 2, whatever that decimal value is. So x is 12 times the square root of 2. On to the next one. Here's a slightly trickier one. Still a 45, 45, 90 triangle. So in this example, if we use our table, whatever our leg is times the square root of 2 will give us our hypotenuse. So we're missing our leg. Well, we know that this equation right here equals the hypotenuse. Right? You could say this, if that makes more sense. This equals hypotenuse. Well, we know the hypotenuse, so we substitute that value. So x times the square root of 2 equals 8. 8's our hypotenuse. And then we solve for x. Some people like to square both sides to get rid of that radical. I think that's a little bit longer process, but it's perfectly legitimate to use. I think it's far faster to just divide by the square root of 2. However, some people don't like to deal with radicals, so they like to get rid of them. So on this side, we canceled all that, and we are left with x. That's what we want. Over here on this side, we have 8 divided by the square root of 2. We can't leave that radical in the bottom. That's not simplified. So we got to use our rationalizing step. Multiply top and bottom by whatever this is, the square root of 2. So on the bottom, we get just 2. Remember, squaring a square root, multiplying it by itself gets rid of that radical, and we're left with a number underneath. On the top, we have 8 times the square root of 2. So I'll write it a little bit neater over on the other side here. So we have 8. Really, we have this fraction 8 over 2 in the front and radical 2 off to the side here. So we reduce that fraction, 8 over 2, and we finally get the value of our leg, 4 times the square root of 2. So compare these two values here. What is the leg compared to the hypotenuse? And some of you might be able to do this shortcut here where really the leg is half of what the hypotenuse is with the square root of 2 attached to it. So what's half of 8? 4. And we stick on the square root of 2 there. So that shortcut works as long as this is a nice whole number, which in most cases is what we'll see in all of our examples for this class. Alright, so that's a 45, 45, 90 and the two relationships that you will have to solve for. Another different type of right triangle, it's called a 30, 60, 90, and that's because aside from our right angle, our 90-degree angle, we'll have a 30-degree angle and we'll have a 60-degree angle. And these could be at either side, it doesn't matter what side they are, they're going to vary in your problems. But if you see a problem where all you're given is the 30, you're going to have to make that assumption that that missing angle is 60, or vice versa. If you're given a problem where all they give you is the 60-degree angle, then they're going to assume that you can come up with the 30 degrees right there. So that's really the first trick. If you can do that, fill in your angles here, it will lead you to the next step, which is to label the parts of our special right triangle here. We're going to have 3 different parts, and they're listed over here. We're going to have 2 legs. One of them is going to be shorter than the other, so we're going to have a short leg and a long leg, and we're still going to have a hypotenuse. So if you think back to when we were talking about triangles and how a shorter side is always across from a smaller angle, that helps you label your short leg. So the short leg is always going to be across from, it's going to be across from the 30 degrees. So if you look across here, this will be our short leg. And we're going to shorten it up to SL. If you look across from the 60-degree angle over to this side, that's going to be the long leg. So the long leg is across from the 60 degrees. And the hypotenuse is still across from the 90 degrees. So this was our long leg, and this is still the hypotenuse. So if you can label your pieces, then that will help you get to the next step, which is to use 3 different equations here. We'll set it up in our ratio table. The short leg is always going to be our default. That's what we want. Everything else is based on the length of the short leg. The long leg is going to be whatever this value is at the front of the square root of 3 now. So just like in our 45, 45, 90, the leg was attached to the square root of 2 for the hypotenuse. In this case, in our 30, 60, 90 triangles, the short leg is going to be that value. The length of the short leg is going to be that value in front of the square root of 3. And our last one is going to be the hypotenuse, and it's always going to be excuse me, double the short leg, or 2 times the short leg. And vice versa, if we know our hypotenuse, the short leg is going to be half of whatever the hypotenuse. We'll see that in an example coming up here. So label those pieces so that you can throw them into these 3 formulas here. So let's do an example. The easier example, the quicker example, is if we know the shorter leg, because everything is based on that shorter leg. So the short leg in our table, if we redraw our formulas here, long leg is going to be whatever that short leg is times the square root of 3, and the hypotenuse is going to be double the short leg. Well, we know the short leg because it's the side that's across from the 30-degree angle. And the long leg is going to be y. It's going to be across from the 60-degree. So that makes x the value that we're missing for our hypotenuse length. So we know the short leg is 6. So we just substitute 6 for all of our x's in these equations. So y is going to be the long leg. So again, it's the short leg in front of the square root of 3. And that decimal value right there is the length of y. There we go, that's y. And our hypotenuse, which is this length here, is going to be double the short leg. Well, the short leg is 6. So 2 times 6 is our hypotenuse value of 12. Alright, so our hypotenuse ended up being 12. It's double the short leg. If you take a quick look, the short leg is half of the hypotenuse. Alright, so we know the long leg because it's across from our 60-degree angle. So in our table here, we know that the long leg is 8. Remember, our formula was whatever the short leg is times the square root of 3, and that equals 8. So that's the long leg. So this will help us solve for the short leg. We're missing the short leg in this equation. So if we divide by the square root of 3, that gives us x on one side. But now we need to get rid of the square root of 3. So we rationalize, multiply top and bottom by the square root of 3. That gives us a 3 on the bottom. And on top we have 8 at the front of the square root of 3. And again, we can't simplify that fraction, but we're always looking to. So in this case, we can't simplify any farther. So the short leg value ends up being this crazy fraction here, 8 times the square root of 3 divided by 3, which ends up being just a decimal value. And then our hypotenuse, remember, is double the short leg. So how do we double this? Well, if you know how to multiply fractions, you can double it. We're multiplying by 2. Whole numbers are always over 1. And when we multiply fractions, we multiply straight across. When we multiply numbers with radicals, we can only multiply numbers in front of radicals together, and we can only multiply numbers under radicals together. So in this case, all we can multiply are 8 times 2. It gives us 16, and we keep that radical 3 as it is. We also keep 3 because 3 times 1 is still 3 on the bottom. And again, we check this fraction right here in the front. Can we reduce it? In this case, we can't. So our hypotenuse ends up being 16 times the square root of 3 over 3, which again is just a crazy way of writing what ends up being just a decimal value. You can also notice that really all we doubled is that number in front of the radical, and that might be a shortcut you want to take when you do some more examples. Let's do one more. Let's say we know the hypotenuse this time, and we're solving for our two legs, our short leg and our long leg. So again, fill in your angle so you know what is the short leg. So that ends up being this over here. Across from the 30s our short leg, across from the 60s our long leg, and this is our hypotenuse. Remember that the short leg is half of the hypotenuse. So even though it starts off looking tricky, it's really quite easy. Y ends up being just half of 10. We could do the equation if you want. Remember, it's 2x equals the hypotenuse, so 2x equals 10. And if we solve for that short leg, we just divide by 2 and we get 5. And then the long leg, remember, is just the short leg with the square root of 3 attached to it. So the long leg ends up being 5, that's our short leg, with the square root of 3 attached to it. And that's another decimal value. And so really the hardest one is if you're given the long leg and you have to figure everything else out. The other two are quite easy examples, as long as you know those ratios in your table. So those are special right triangles, 45, 45, 90. Make sure you know its formulas, and the 30, 60, 90. Make sure you know its formulas. So go ahead and practice those.